There we go. Okay. So today, like I said, we're going to be doing some modeling with quadratics. And what modeling basically means is developing an equation for a given situation. Okay, and we're going to be just doing those with quadratics today. So a couple different things we're going to be looking at. First of all, we're going to be writing equations of quadratics using 3 points. Okay, so depending on what information is given to you, we might want to use a different type of form of a quadratic. We've looked at some different types of forms. We've talked about standard form of a quadratic. We've talked about vertex form of a quadratic. We've talked about intercept form of a quadratic, and we're going to review that stuff today. And so we're going to just kind of lay out, okay, if you're given this kind of information, you want to use this form. If you're given this kind of information, you want to use this form. So we can kind of piece that out a little bit. And then we're also going to talk about quadratic regressions. Who remembers from chapter 1 when we did linear regressions? We found an equation on the calculator? Not so much. Well, some people are nodding. So we're going to do that too. We did line of best fit. Maybe that's what you remember more than linear regression. But we're going to find quadratics of best fit. So if we have a whole big old table of values, how do we then take that, put it in the calculator, and find a quadratic equation that's going to fit that stuff the best? Okay. So, like I said, first of all, let's talk about what we're given and then what we're going to use. Okay, so if we are given specifically a vertex and then some other point that the quadratic is going to go through, what form do you suppose we're going to want to use? Say that a little louder. Vertex form. Yeah. If you're given a vertex, vertex form makes a bit of sense, right? All right, and we'll do some examples of that. All right, okay. So, but you have to have another point with it to use that, and I'll show you how that works. All right, if you are given two intercepts and another point. So when I say intercepts, I'm talking x-intercepts, right? So if you have the two x-intercepts and some other point that's on the curve, what form do you suppose you're going to use for that? Remember the three that we talked about were standard, vertex, and intercept. Intercept form makes a bit of sense, right? Whoops. Intercept form. Okay, so we're going to hold off on the whole regression stuff for just a second. We're going to just focus on this, okay? So the information might be presented to you as a graph. So you have a graph of a quadratic, and you can see some points right on the graph that you can pick off and use. Or they'll just tell you this point, this is the vertex, this is another point, etc. So you go from there, okay? So I'm going to start by doing a graph here and see if we can use that. Okay, so let's try this. So we've got the points 1, 0, 5, 0, and 6, negative 2 that are on the quadratic. Okay? So, what form do you suppose we're going to use on this one? Based on the type of points that I gave you. Intercept form, right? Didn't give you a vertex. Gave you a couple of intercepts on there, though. Okay? So, we need to review for just a second what is intercept form. And it looks like this. And we did have a question about this, or a couple of them, on your quiz. It was the first one on the backside, and a lot of people did very well with this. A few of us forgot the connection. If you forgot it, then you kind of went down the wrong path and had some trouble with it. But if you remembered the connection, it was a really easy problem. What the P and the Q in there, what are the P and the Q? Those are the intercepts, right? So, my intercepts are at 1 and 5, right? So, I can right away do this. Okay? So, start with that intercept form. If you know your intercepts, those are P and Q. Just boom, boom, put them in. And one thing we talked about is, once you have that all written out, the sign inside the equation is going to be opposite from what you see on the graph, all right? Because it's x minus 1, x minus 5. The intercepts are positive 1, positive 5 again, right? It's that whole switching it around thing with the horizontal stuff. So that starts out our equation for us. So it actually gets us a good ways into it now. What's the only other thing that I really need to figure out about this equation to be able to have it done? A. What is A? Okay. Well, there's some information that I haven't used yet. Okay. I have this other point that I know that it has to hit. It's got to go through 6, negative 2 as well. Okay. So knowing that, I have an x and a y available to me that I can plug into my equation. Okay. And remember, f of x is really just a fancy way of saying what? Y. Okay? So, negative 2 is my y, and 6 is my x. Sorry, excuse me. So what we can do now is solve for a. Okay, I can work out what's 6 minus 1, what's 6 minus 5, do a little multiplying in there, and I can work it out and figure out what a needs to be to make this thing work. So 6 minus 1 is 5, 6 minus 5 is 1. So I've got negative 2 equals a times 5. So, what is the value of a? Negative 2/5. Yep. All right, so now I can take that little a and put it back in to what I had right here. All right, so my final equation with the a plugged in for this parabola is going to be f of x equals negative 2/5 times x minus 1 times x minus 5. You don't need to multiply this all out together. You can leave it in intercept form just like that, and it's fine. Okay. So one little interesting thing that popped up here, though. Our parabola opens down, right? What do we know about a if a parabola opens down? Negative. Should be negative, right? We talked about that last week. Okay. And the math that we used in solving for a verified that fact for us. It came out to be a negative number, which makes sense. So that can be a little bit of a double check for you, okay? When you're looking at the graph, think about that. My a is supposed to be positive or my a is supposed to be negative. Let's work it out, plug the numbers in, and double check, make sure it does. In this case, yeah, it came out negative the way it's supposed to, okay? So that's the equation for that particular parabola then, okay? All right, let's try another one. say we've got this one. This point down here is at 3, -4. And there's a point up here that is maybe 6, 1. So, what form do you suppose I should be using with this one? Vertex form. Because one of the 2 points I gave you there is a vertex, right? So we can start with vertex form. Okay, so we got to go back and think about what does vertex form look like again. And it looks like that. By the way, you guys have got a lot of different little equations and things that you're going to have to remember. What I'm going to do, just so you guys know, on your test, I will give you a page, or I'll write them on the board, one of the two, where I'll give you all these little, like, vertex form, intercept form, etc., okay? I won't label next to them what they are. You need to look at it and recognize, oh, that's vertex form, or oh, that's standard form. You need to know which one is which, but you don't have to try and recreate the whole thing, okay? So I'll have all those on a page for you. But in any event, that's your vertex form, okay? So where do the coordinates of the vertex go in that equation? So my 3 and my -4, what should I be doing with them? -4 is K. 3 is, actually in this it's the H. It goes with the X. So it's X minus 3 squared minus 4. The way we talked about that before was, think about it like a translation, okay? This is a parabola that has been essentially moved to the right 3 and down 4, right? So think about how that affects the equation. So it's going to be on the inside minus 3, opposite, because it's horizontal. So to the right 3, minus 3, down 4, minus 4, okay? So if that helps, vertex form is really just showing you the translation that happens there. Okay, so that's where we're at. So again, we got this other point hanging out there. What can I do with it? Yep. You got it. So we're going to do the same kind of process. I use the other point as an X and a Y, and then that'll help me figure out the A again. Okay? Kind of like we did in the last one. All right, so this one I got to be a little bit more careful, order of operations and all of that. So 6 minus 3 squared. What does that give me? 9, right? 3 squared. So 1 equals A times 9 minus 4. But be careful you don't do 9 minus 4, right? Order of operations tells us that we can't do that 9 minus 4 because the 9 is being multiplied with the A. You could if you wanted to. Yep. If that's helpful, yeah, you can do that. So what should I do to solve this for A then? What's my next step? Nope. I'm going to add the 4. So plus 4 to the other side, that's 5. 5 equals A times 9. 5/9, yeah, in this case. You're going to find your A's from time to time are turning into fractions, like we had in both of these two examples here. So, all right, so f of x for this one then is going to be 5/9 times x minus 3 squared minus 4. And this time, the A that we came up with was positive. Does that make sense based on the graph that we have? Okay, again, quick little double check, right? I got a positive A, my parabola is opening up. Okay, that makes sense. Good. So, all right. All right, so I'm going to do one more kind of like this for you guys to try on your own. I'm not going to give you a graph this time. I'm just going to give you some information to work with, okay? And see if you can come up with what the equation is. Pick the correct form, whether it's vertex form or intercept form, and then work your way through it, okay? So what is the equation of the parabola through points -2, 0, 4, 0, and 5, -3. Now, if you want to graph those, like draw a little sketch again of those points and think about the parabola that would fit through those, that's fine. Okay? You're welcome to do that if that's helpful. I'm a visual person. I would probably go that route myself. But see which form you need. Give yourself a few minutes, see if you can do that. What form do we need for this one? For sure, intercept form, right? Because 2 of those 3 points that I gave you are x-intercepts, right? And you can tell because they have y-coordinates of 0. Okay? Now, if you graphed them too, it would make it even more obvious that those are x-intercepts. Okay? So starting in intercept form, so plug in those intercepts into that, and then you got to go through and solve for a and all that. So let me show you what I came up with here. You can check it, see if it matches what you had. So my a that I came up with was negative 3/7, and the intercepts were at negative 2 and 4. So it should look something like that then. Negative 3/7 times x plus 2 times x minus 4. So any questions on that one then? We're okay. All right. I want to transition really quick to talking about data. We didn't do the regression stuff yet, so we got to talk through that a little bit. So if I give you a set of data, you can use your calculator to determine what would be the quadratic that would fit it the best. Okay? So we're going to talk through a little bit about how you can make a scatter plot on your calculator to look at the data, to see what shape it's in, and if it looks like a parabola, then you can use a quadratic regression to help you do that. Okay? So let's do a quick example of that. All right. So let's say we're taking a look at gas mileage. So I don't know if you guys knew this or not, those of you that are driving cars at this point, but the miles per gallon that your car gets is dependent upon how quickly you're driving. Okay, so if you always drive like 10 above the speed limit, your gas mileage might not be as good as someone who's driving like right at the speed limit or a little underneath or something like that. So a person went through, apparently here in this example they have in the book that I'm stealing, they made a little chart. So they kept track of what was the miles per hour they were going, and then what was the gas mileage that they were getting at that speed. They made a little chart. So miles per hour and then the miles per gallon that they were getting at that speed. Okay, so we have 20, 24, 30, 36, 40, 45, 50, 56, 60, and 70. Okay. So, and here's their miles per gallon that they were getting at these different speeds. So at 20 miles per hour, they were getting 14.5 miles out of every gallon. At 24 miles per hour, they were up to 17.5. 21.2, 23.7. All right, so that's the data they came up with there, okay? We'll give you guys a second to write all that down. While you're doing that, though, just looking at that data, what do you see? What jumps out at you about this? So the faster you go, the worse the gas mileage? Yes and no. Take a look at the whole chart for a second. What happens to the miles per gallon as we go down? Right, it goes up, right, and then it goes back down. So there's somewhere in the middle there's got to be this like money speed, right, where it's like the perfect speed to get the most gas mileage, right? So whereabouts is that going to be, do you suppose? Where is going to be like the best speed for your gas mileage? Somewhere between 45 and 50, right, because that's kind of where it maxes out at that 25.8 for both of those. Okay, so what we're going to do is we're going to create a quadratic equation for this, and we're going to look for a vertex. Because that vertex should be that money speed, right? Wherever that maximum is, right? Where that maximum gas mileage happens should be where our vertex of our parabola is, and that's the speed that we're going to be looking at for maximizing our gas mileage then. Okay? So, take out your graphing calculators for a moment. We're going to put the data in and take a look. I'll try and do this side by side as best I can here. All right, so little review from Chapter 1. We haven't done this in a while, but to put the data in, there's a button that says Stat, and it'll bring up this menu, and then you want to hit Enter on Edit, and I've got some other things in mind. So yours should look like something like this, where L1 and L2 are the first two lists that show up. Okay, if there is something in one of those two lists, you can get it out of there by going up to the top. Like now I've got L1 highlighted. Don't hit delete, hit clear. If you hit delete, it just gets rid of the whole list altogether. Clear, and then enter, just empties it. Okay? So I emptied list 1. I'm going to empty out list 2 as well. All right? And now we can start putting numbers in there. Okay? So list 1, let's make that our miles per hour. List 2 will be our miles per gallon. So if you want to just start typing them in, okay, write down the columns there. All right, now the way that we put these in here, the miles per hour is kind of playing the role of X, and the miles per gallon is going to be our Y. Okay? So, we can do a little scatter plot first of all. We want to look at this data, make sure that it actually looks like a parabola. It kind of makes sense that it would, right? It goes up and then it goes back down, so a parabola shape would make sense. Okay? But to be sure, okay, if you go into y equals, but you're going to hit second and then y equals, that takes you into this little stat plot menu that should look like this. Okay, y equals is the top left button on the calculator, up right under the screen. But hit second and then y equals. Should see this. All right, hit enter on plot 1, and it should take you in here. First things first, we want to turn it on, so make sure that on is highlighted instead of off. And then under the type, that first little one should be darkened in. And you can just arrow down past that, okay? So plot 1 should be highlighted, on should be highlighted, and then the little scatter plot looking one, the first one there should be highlighted. And then where it says X list and Y list, does everyone just have L1 and L2 right there? Yep. It should default to that. If it's something different, I can help you change it, but it should just be that. Okay, and then at the bottom, you have a mark. Okay, so basically that's just what do you want to see on the screen. When it plots all these little points, do you want them to look like boxes, little plus signs, or just like tiny little dots? I like the boxes because they're easier to see. The tiny little dots, you kind of lose them sometimes depending. But the squares are easy to see. Okay, so, all right, so we got that all set up the way we want it. Then if you'd hit just regular y equals for just a second, if you have any equations that are in there, like see how mine I have tangent and some other things, clear out anything that's in there. So all you see is just the plot 1 highlighted at the top, but nothing else in there. Okay? Unless you've used it recently, there shouldn't be anything in there. But okay. So the plot's turned on, everything's set up the way we want it. Now we need to make sure that the window is the right size to show us what we want to see. Okay? So here's the thing. This is why I made sure that I mentioned to you guys that this is our x, the miles per hour, and this is our y, miles per gallon, because we need to give it an x min and max and a y min and max. So if this is x, what do you suppose would be a good x min and an x max? Usually you want to go just a little either way. So maybe 15 and 75 or something like that. Okay? 20 and 70 would be okay. You'd be able to see it just fine. But if we really want to see it well, yeah, just a little below and a little above. So the x min maybe 15, x max 75. The x SCL, that's the scale. So maybe we count by 5s, since both numbers are divisible by 5 or something. That'd be okay. Or you can just count by 1s. It doesn't really matter. What about the y min and max? What do you suppose would be a good y minimum?
10.
Like 10 would be okay. Yep. 30. Then maybe 30. Yep. So you can see that. And then that one as well, the y scale, whatever you want to count by, maybe 5s, let's say. Okay. So now if you hit graph, you should see all the little points graphed for you. All right, and this is where this is our little double check that, okay, we thought this thing was going to be a parabola. Now that we see all the little points graphed on there, what does it look like? It looks like a parabola, so doing a quadratic equation for it makes sense. Okay, so anybody need help making the parabola, or will we all get there? Didn't see the parabola. Oh. Oh, your plot's turned off somehow. All right, now, there you go. All right, anybody else need help getting to this point? Okay. Yes? Did the plot get turned off, maybe? That's what happened over here.
It's got like some like the window is messed up, but it says the window should be active.
So 1575, 5, 1035. What happened to your screen? Looks like you spilled something on it. That's weird. Oh, I see, because your X list and Y list are mixed around. It should be L1, L2. You had L2, L1. There you go. All right, so now that we know that it is definitely quadratic, let's go figure out what is the quadratic that goes with this. Okay, here's how you do that. It's pretty simple. Just go back to stat real quick. Since the data is already in there, all you have to do now is you go over to where it says calc. Stat is right under delete. So stat, then over to calc, and then we want to do this thing called quad reg, which stands for quadratic regression. Okay, so hit enter, and then enter one more time to actually do it. And it gives you all this business. Now that r squared may or may not be on your screen. Don't worry about it. We're not going to use it. Okay? We do need the a, the b, and the c. What form is the quadratic regression giving you? Standard. Okay? The two forms we talked about already today that we've studied in the past, vertex and intercept, but there was also this standard form, right? That had the a, the b, and the c. Okay? That's what they're giving you here. Now, for each of these A, B, C, they have this huge long decimal, okay? You can round those things off. Don't worry about that, okay? but we're going to copy down this equation with the a, the b, and the c put in there. Okay, so we're getting y equals, now my a is negative, I'm going to go 4 places for each just to be safe, but even that's kind of overkill. So 0.14, and then if I round it, it would be 1 x squared. And then the b that I had was plus 1.3662 x, and then the c it gave me was negative 7.144, and then if I round it would be 1. Okay. Then we'll have to check your data. Maybe there was something typed in wrong. Everybody else have those numbers? Okay. Yeah, we can always double check it. If it doesn't come out right, it's probably because something got typed in wrong originally from the data. All right, so remember, we were going to use this equation to try and figure out where's the vertex, to figure out what's going to be that miles per hour that we want that's going to be the best, okay? And we were guessing it would be somewhere between 45 and 50, okay? If I have a standard form quadratic, what was the process we used to find the vertex? You guys just did it on your quiz last week. We started with negative b over 2a. Okay? Now I realize, yeah, there's some big decimals on here, but you have a calculator in front of you, which will handle that no problem. So our negative b over 2a, negative b, negative 1.3662 over 2 times a. Okay, that's my negative b, there's my a, just put them in there, and you got a calculator. So, be careful, I would just multiply the denominator by 2 first, and then divide the two numbers, okay? But negative 1.3662 divided by 2 times negative 0.0141. I'm getting 48.45. Did you put parentheses around your denominator? If you didn't, you'll get the wrong answer. It's a very common mistake. Did you do it like I did it? That's what I was saying. If you didn't put parentheses around the denominator, you'll probably get the wrong thing. Because then you're only dividing by 2 and actually multiplying that answer by negative 0.0141, which will give you a smaller number than you should have. Okay. All right, so what is our speed that we should be traveling to maximize our gas mileage? Apparently it's 48.45 miles per hour. Okay, because remember, this is the x coordinate of the vertex, right? And x was the miles per hour. So this is our miles per hour we want to travel at. Now let's say I wanted to know, okay, so that's the miles per hour I should be traveling at to maximize my gas mileage. I want to know what is the gas mileage I would be getting if I traveled at that speed. How would I figure that out? Yeah. Yeah, take that equation, plug that in for x, and get the y that goes with it, right? Because that should be then the gas mileage. Okay, so let's do that really quick. This will be the last thing we do. And then you guys can start homework. And again, when you got decimals like this, just be careful that you're typing everything in correctly. It's easy to make a mistake.
Yeah, my mistake was I for the 1.5 instead of 1.0.
There you go. Yeah. You always got to kind of double check things with that. So let's see, if I put in 48.45. As you guys are typing this in, are you glad we didn't keep every single decimal point there? Yeah. All right, so here's what I got when I plugged that in. Ended up with 25.95. So apparently if you drive about 48.5 miles per hour, you can get nearly 26 miles to the gallon with this car. That's going to be your best that you can do. Okay. So anybody that knows anything about cars, is that pretty decent or not?
No.
Compared to cars of today, not so much, I wouldn't think. Most cars, like, well, what would you guys say? What would be good gas mileage for a car these days?
30.
At least 30, right? Yeah, my little Cobalt gets me 32. I figure that's pretty good. So, yeah. So this is not great, but, you know.
Get a Hungary